Hello, and welcome to a little video about the transformations of exponential functions. Number one is going to be our parent function. That means all the other ones we're going to graph are going to be transformation of this specific graph. All right, let's start by plugging in the x's into the function 2 to the power of x. Just to remind you, if you're doing this on your calculator, you would be entering a 2, hitting the little caret button, and then typing -2. You should get 1/4. Right. If you're doing this on your own, make sure to pause this video, practice typing all these exponents, and then unpause it, um, and we'll have them all filled in. All right. All right. So those are our 5 points. Let's graph them, and we're also going to graph our asymptote, and we'll talk about that in a sec. But let's start. Now, I'm going to graph these fractions. You don't have to if you don't feel comfortable with it. Okay, -2 1/4. I'm going to go to -2, then I'm going to go up what I think is a fourth. -1 1/2, 0 1, 1 2, and 2 4. Here is my parent function. Now, if we continued entering smaller numbers like -3, -4, etc., so going more left on our little graph, we would just get progressively smaller fractions. We would never, ever get 0. We would just get smaller and smaller. The reason we could never get 0 is because there is absolutely nothing that we could plug in to 2 to the power of x to get an answer of 0. This is where our asymptote comes in. Our asymptote is this invisible dashed line It's horizontal. It's at y equals 0 because we can never cross it. It creates this border. If you ever take a look at this graph on a calculator or on Desmos, you'll see the flattening happen. The asymptote is there. It's preventing the line, the exponential curve, from crossing 0. Okay, let's check out these next few, and I'll talk about the asymptotes as the problems go on. Okay, so in number 2, we still have 2 to the power of x, and then we have a plus 3. Let's see how that affects our parent graph. This is how we're entering this in your calculator. You have to make sure when you put in 2 to the -2, you click the right arrow and get a plus 3 on the outside. The most common mistake here is not getting out of the exponent and typing a plus 3 up there. Right? That's not what we want. We want a plus 3 on the outside. Okay? Put that into your calculator, and what you get is, you get a fraction. I have a mixed number in my head. So that's going to be 13 fourths. Yes. Right? Yes. Okay. Next we have 2 to the... You go ahead and pause it, do these in your calculator, and you can unpause it and see what I got. Here we got 7/2. Then we got, so this is actually 3 1/4. This is actually 3 1/2. This is 4. This is 5. And that's 7. Okay. I feel pretty comfortable graphing the 3 1/4, 3 1/2. Well, let's go for it. -2, 3 1/4. -1, 3 1/2. 0 4. I almost said -0. 1 5. And 2 7. Before I draw it, check it out. It looks like, actually, I'll draw it. change my mind. It looks like we took the graph in letter A and we scooted it up. And that's exactly what happened. That means that we're going to be flattening instead of 0. We're going to be flattening at 3. Here's how I know we're going to flatten at 3. Take a look at the table. As my x's get smaller, so from -1 to -2, my fraction is getting smaller, but the whole number isn't. So we have an asymptote for number 2 at y equals 3. It moved up with the graph. And as you know, the coordinates that go up and down are our y's. Letter 3. Number 3. Same idea. Now we have a -3 on the outside. Make an inference in your head. If +3 moved our graph up, what do you think -3 does? Okay, but here's the calculator part. Make sure you're subtracting 3 on the outside. Okay. So this is going to be 1/4 -3. So that's -11/4, which is -2 3/4. Okay. And we've got 1/2 -3. So that's -5/2, -2 1/2. Here we got -2, -1, +1. Okay. Same idea as number 2. My x's, as they're getting smaller, that whole number is staying the same. The fraction, though, that's getting smaller and smaller. Because they're negatives, right? They look bigger, they're actually smaller. So, we're having a flattening happening somewhere else. Let's see if we can graph this. Okay, negative, oh, I cut the graph off, that's fine. -2, -2 3/4. -1, -2 1/2. 0, -2, 1, -1, and 2, 1. We are going to have an asymptote at y equals -3. Just like the asymptote moved up with the graph here, this one moved down with the graph. Now you might be thinking, hey, okay, up here you said, look, it's the whole number is 3 and that's what we're approaching. But yeah, we're here, we have a -2. The -2 is telling me that we're approaching -3. All right, number 4. Number 4 is different than number 2. It has that +3 floating. So what I was trying to avoid in number 2. Let's see how this affects our graph. All right, so we have 2 to the -2 plus 3. So that's 2. 2 to the -1 plus 3, 4. 2 to the 0 plus 3, 8. 2 to the 1 plus 3, oops, 16. 2 to the 2 plus 3, 32. Okay. Let's see what we get. -2, 2. -1, 4. 0, 8. Okay, the rest I can't graph, but here it is. It's a little weird or hard to see, but take a look at letter D. I'm going to scroll up to A. Okay, ready? Here we go. What change happened? To me, what it looks like is our graph moved to the left. And that is what happened. When we go left and right, those are our x's. So our asymptote stays the same. We didn't move up or down. All right, last one, we got 2 to the x minus 3. Well, if adding 3 moved it to the left, make an inference about what subtracting 3 does. Okay, calculator time. 2 to the negative 2 minus 3 is 1/32. 2 to the negative 1 minus 3 is 1/16. 2 to the 0 minus 3 is 1/8. 2 to the 1 minus 3 is 1/4. 2 to the 2 minus 3 is 1/2. This is going to be tough to graph. Well, let's give it a shot. 0 1/8, 1 1/4, 2 1/2. Oh my gosh, they are so tiny. What if we add 3? Let's see what we get with 3. Oh, that's 1. Okay, that's better. That gives me something. What about 4? Okay. All right, there we go. Well, compared to our parent function in number 1, it looks like we moved to the right. Our asymptote's going to stay y equals 0. So, on the previous page, a of x equals 2 to the x is a parent function. I totally forgot I had this page. So we're gonna fill out what we were just talking about. But in class, we would have been going back and forth. Totally forgot about this. Good thing I do this before we teach the lesson. Yes. All right. Parent function is the simplest. Yes, yes, yes. Similarities between A and B. This is where we went up. Moved up 3, and then we moved down 3. For number A, we moved left. And then we moved right. Asymptotes change in graphs B and C because they moved up and down. All right, so here's the transformation that we just explored. The parent function is f of x equals b to the power of x, and here's the transformations. Vertical translations. This happens when we move up or down. This happens on the outside of our function. If there's a plus, actually here, let's do it here. If there's a plus, we move up. Plus. If there's a minus on the outside, we move down. If we're moving left and right, it's kind of weird. If we're subtracting in the exponent, it's to the right. And if we're adding, it's to the left. I know it's counterintuitive. I know. But later on in math, the more you learn, you'll see why this happens. Next year, when you look at factoring and stuff like that, you'll start to get it a little bit more. All right, let's write the new equations. If we're going to translate 4/5 to the power of x. For letter A, if we translated it 2 units up, we would have 4/5 to the power of x with plus 2 on the outside. If we were to translate this function to the left, we would have 4/5 to the power of x plus 7. I know, weird. If we were to translate it to the right 3 units, we would have 4/5 to the power of x minus, why is it doing that? Minus 3. And finally, if we translated it 15 units down, we would have 4/5 to the power of x and then minus 15. In number 2, let's write the equation and then the asymptote. Remember, the asymptote moves if we're moving up and down. The original asymptote is 0. We're adding the up, subtracting the down. All right, function equation. We're starting with f of x equals 5 to the power of x. We have a translation of 4 units to the right, and then 3 units down. The asymptote's directly related to the down. All right, let's start. To the right is subtracting in the exponent. Down is subtracting on the outside of the base. Our asymptote is also going to be that minus 3 that we're subtracting from the whole base. That's it. Let's try number 3. We have g of x. Forgot to give this a mark. 3 times 2 to the power of x. We have a translation 10 units to the left and then 7 units up. So we've got g of x equals 3 times 2 to the power of x. When we're moving to the left, we are adding in the exponent. When we're going up, we add outside of the base. I want to make this smaller to fit in nicer. Like my sound effects? Yes, I love your sound effects. Oh, thank you. Our asymptote is y equals 7. Again, that same 7 that we traveled up. Okay. Number 4 and 5 are going to seem silly, but let's do it. We're going to translate the graphs instead of translating the equations. All right, this is how we do it. I find a couple of nice points. So points that like are whole numbers. So let's use this one and then this one. Yeah, those are the only nice ones. Then I'm just going to move them down and create my graph. First of all, I noticed that my original asymptote is at y equals 0. It's flat. It's like that parent function. So I know that I'm going to have my asymptote at y equals -7. So I'm going to go ahead and draw that now. Now I'm going to go ahead and move the 2 points that I drew down 7 spots. 1, 2, 3, 4, 5, 6, 7. You sick of it yet? 1, 2, 3, 4, 5, 6, 7. And then I connect them to form a similar graph. There we go. I took the black line that I had printed and I moved it down 7 spots. In number 5, let's translate 4 to the left. If we're moving left and right, our asymptote doesn't change, so I'm just going to go ahead and redraw it. We're going to do the same thing. Identify some points, move them left. Let's use this one and this one. Can I get a nice third one? Yes. Okay. 3's better. I don't know why, but I feel like 3's better. All right, 4 to the left. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then, of course, we connect them. And there's my graph. Moved 4 units to the left. Oh, I didn't realize I had an asymptote. Good job, me. I didn't have this last year. I must have added it this year. Good job, past Gumin. All right. Is number 12 our last one? Yes, okay. Number 12 is a little bit crazy, but we'll get there. It's fine. We're going to translate this graph. 3 up and 5 to the right. Then we're going to talk about the domain range and asymptote. First, before we draw anything, let's talk about the original. The domain, let me remind you, talks about our x's. Our domain is the most left x all the way to the most right x. Now I know this doesn't have arrows, the original function here, because I screenshot it off of a graphing thing, but we would have arrows here, right? Because they go for forever. So it looks like I have an arrow going to the left and an arrow on the right. This means my graph exists forever on the left and forever to the right. In math, forever is infinity. On the left, we have negative infinity. And on the right, we've got positive infinity. Our range talks about our y's. Well, this is a little different because you could probably tell once I get there, there are no y's in this area. All of my y's are below 0. They're all underneath it. All right. All of my y's are less than 0. My asymptote is at y equals 0. I can tell because that's where it's flattening out. Right. Now let's translate it. 3 up, 5 right. Let's pick some points. This one, and this one. Oh, good, I have 3 points. All 3 of them are going to move up and right. All right, 3 up, 5 right. Let's go. Up 3, 1, 2, 3. To the right, 5. 1, 2, 3, 4. New point. Up 3, 1, 2, 3. 1, 2, 5. New point. 1, 2, 3. New point. Okay. I moved 3 up. That means my asymptote should also move 3 up. So if it was at 0, it should now be at 3. Okay. Now let's connect our points. Here's our graph. I'm going to erase these marks so you can see how we moved up and right. All right, let's talk about its domain. Now for the domain, it looks like I still have an arrow on the right side and an arrow on the left side. Our domain is from infinity to positive infinity. For my range, that's my y's. It looks like everything exists below 3. My asymptote is at y equals 3. I have another thing to say about domain. Another way we can phrase this domain is all real numbers. The reason we can say that is because I can plug anything into x. It's just y that has a restriction, not x. Awesome. Okay. We're going to practice this. Don't worry. If you have any questions, please let me or whoever else is helping you know. And have a wonderful rest of whatever day it is for you. Bye.